That almost worked. Welcome to episode 30 of Quarkus Insight. Yeah. We got a guest and all.
Hello.
Hello, Loïc. Well, we'll start with a few news. So last week we were supposed to have a Vodafone a guest here, but we had a problem with Restream. They finally got around to tell us that there was a back-end issue on their side. So that should be fixed, and we will get them on, hopefully, before Christmas, I hope. But that's the plan. And anyway, we got actually
some live people here from the cloud, Google Cloud, YouTube, and I don't know this logo, the blue one with a red flame in it.
Someone.
What is it? Tumblr or something?
Not Periscope, I think. Twitter. That's where they're from.
Okay.
So anyway, that was the little administration. Then we have a few news before we go to the main event. So Emmanuel, you want to cover the reactive news?
Yeah, so we've been busy working on some reactive stuff. One more, I guess, more in the open than the other. So first of all, we want to officially say that Hibernate Reactive is out. The beta 1 has been out. You can read the news into the Hibernate blog, which is in.relation.2, and you'll see Gavin's blog about it in detail. It's a big thing for us and for you, because as part of the reactive story, the difficult part has always been the data access, because yes, we had some native drivers to access some, especially non-SQL databases. SQL databases were something that got brought up, but there was not necessarily higher level things that were written in a non-blocking reactive fashion. And here the proposal for Hibernate Reactive is to look at the JPA operations and semantic and offer a non-blocking API that would feel very natural to a reactive model. And that's what Hibernate Reactive is about. And it uses Vertex reactive drivers. So we have Postgres, MySQL, I think Microsoft SQL, DB2, and I might be missing.
I think that's about it for now.
Yeah, that's about it. Okay. So the cool stuff is that those drivers are non-blocking, which means that the only way to really be non-blocking, by the way, it's like end-to-end. You have a non-blocking call coming up, and then you go all the way down, and it's non-blocking. And that's how you get the most of the benefits. Otherwise, you have to fall back into a worker model where you hand over some specific work to a worker pool. And then you're back into having a bit of a difficulty handling the back pressure, or back to like one thread per operation, which has a different cost from a resource point of view. So we're very happy to have Hibernate be this, be part of that non-blocking story on the data space. And to complete that story, we've worked to rethink and improve the web stack from a reactive point of view. So the lower level, the foundation level, is reactive, and because we use Vertex at the base, and then we were using REST-easy, and for REST-easy by default we were offloading the work to a worker thread. Indeed, what we saw in our benchmark is that we reached a limit that we wanted to go way beyond, and we knew we could with a full non-blocking model. So that's the new project called REST-easy Reactive. And REST-easy Reactive is looking at JAX-RS and the semantic of JAX-RS and pretty much most of the spec, and try to implement it in a full non-blocking fashion. So it's a re-implementation of JAX-RS, though they have reused a lot of the REST-easy core areas. But again, as I said, the only way to be reactive from A to Z is to go and have every single call be reactive. So we had to, it's not just taking Hibernate REST-easy and changing 5 things and be done. So you had to change all of your call stack to be reactive from A to Z. So when you combine REST-easy Reactive with Hibernate Reactive, with the fact that we were non-blocking at the core, and that we had Mutiny to really help you understand and grok reactive in a more, well, I guess, easier fashion, you see the story building up here. So we're really excited about that. So you could definitely take a blocking situation and having it perform better than a non-blocking one. So it's really, the use case is more about like, you know, how many concurrent connections you want to handle within a given amount of resources. And here, depending on that, you will go for blocking versus non-blocking, accepting a bit of the, I guess, complexity of the code style and whatnot. Did I cover it okay, Max, do you think?
I think you did.
Awesome.
So, yeah, and what I really like about it is that what you talked about at the end is that you can kind of choose both. Like it's done in a way that you can start being blocking, or as you normally are, and then if you need it, you go reactive, or the other way around. So it's a really nice mix to end up with. Okay, and yeah, we'll try and get them, get Gavin and Clement and Steph and the other guys that's involved in the whole reactive on. I'm not sure if you're going to make it before Christmas or after, but we'll try. So you guys can tell me in the chat if which one you want to go first, Hibernate or the Rest Easy Reactive. And yeah, just to remind people. Oh, go ahead.
Timo had a question. Is it going to be a video, or I guess he meant a Quarkus Insight about Kotlin support?
Yeah.
I guess that's a good idea. The best is to go to the, if you have a link to the GitHub, there is a list of Quarkus Insight subjects that you can vote up. It's Quarkus, no, it's github.com/quarkusio/ and that's where I'm lost here. I forgot the detail.
I'll give you the link. So yeah.
And so Max is pushing that. So go to that link and you'll see if it's not there. I think there is one, but I'm not entirely sure. If there is none, just create one. Otherwise, just create it.
Yeah, vote it up. We'll put a link in. Then we like every 3 or 4 weeks, I go take a look and then see what we do next.
Yeah.
So yeah, and yeah, and just put questions in the chat, and then Louis here will up.
Not Louis, Loïc.
Loïc, sorry. We will get to his. We'll stop in his track and ask him questions, but
exactly.
Let him get started.
On the edge.
So Louis, do you want to give you just a quick introduction before you get started?
Before I get started, I wanted to ask one question to Emmanuel. So there will be a new Rest Easy Reactive, but how did you compare this with reactive routes? So if you have two ways to implement reactive endpoints, which what would be the difference?
So it's built on top of reactive route. So first of all, so it's the same technology. It's just like, could we make it? And you've seen maybe at some point they're like, I think Clement, a few other, they were trying to improve reactive route to make it a bit like trying to go a bit closer to the JAX-RS style, a bit more declarative, right? So we took a bit of a step back and said, okay, what would be the best outcome ideally? Is that just plain JAX-RS, except it's reactive, because at least you know one way of doing things and you just decide whether you want a full reactive model or the more classic worker model because you have, I don't know, let's say blocking interceptors or whatnot. So it's a good question right now. Like you still have both, like there is the reactive routes if you want to stay with that model, especially the non-declarative model, which is more like inside your code, you're doing things. And then there is the Rest Easy Reactive that is bringing the JAX-RS style, but in a non-blocking fashion. It's probably we won't spend that much energy into moving more the reactive routes in a declarative fashion because we feel that it's a better model to just have essentially one model, right, for that declarative approach. Does that answer your question?
Yes.
Awesome.
Cool.
It's a great question, actually. You know, we are trying to figure out the best model. It's always well, there is no magic answer, right? There's no always like clear answer, but we felt there was an advantage here.
Yeah, usually I just use reactive routes from very basic stuff, very simple stuff, and say, okay, if I need all the power of JAX-RS, then I go to Rest Easy. So for an API endpoint, and usually reactive routes just for small stuff.
But I think for me, the big win or whatever called the advantage of the reactive routes is the fact if you want to have the full control, programmatic control, you can do that. But as far as I understand, REST easy reactive, you can still do that. So it's just that you want to make the REST easy reactive the preferred way, so to speak, or the default way, the one that has the most features and etc. And if you want a bit more manual control, then you can do the REST easy, the reactive routes. Or rather, I think you want to go to the Vertex controller directly. But yeah. Anyway, those are good questions we should ask for the guys who actually wrote the thing, rather than us who just reviewing the blog.
Hey,
so,
did you bullshitting myself out of the question? All right, so Loïc,
Hey, Loïc, who are you?
Who are you?
Okay, so I'm Loïc Mathieu. I'm from France. I work at Zenica as an IT consultant and a trainer. I work on multiple areas around Java, performance, Kubernetes, cloud architecture, and stuff like this. And I'm a Quarkus committer from some times now, and I contribute several extensions to Quarkus, including MongoDB with Panache and CloudFunctions, Google CloudFunctions extensions. And lately, I work on a bunch of extensions about Google Cloud services like storage, PubSub, Bigtable. So there is multiple ones, and this is a set of extensions that are available inside the Quarkiverse repositories.
Okay. Is it because you had like customer demands, or was it explorations?
Yeah, I make a lot of research on different stuff, and I also contribute to Quarkus because I like challenges, and I like to learn new stuff, and contributing is a good way to learn new stuff. And for Google Cloud Function and Google Cloud Services, it's also because a lot of our customers uses Google Cloud, but there was no support for Cloud Functions and Cloud Services. That's why I was interested by them.
Yeah, there is a few AWS equivalent to what you have written, but indeed the Google Cloud equivalent was definitely weaker from a coverage point of view.
Yes.
Maybe we want to touch upon that. So I'm not sure if you tried this before, but one challenge we had in the past was those guys like you or that was willing to write an extension, but didn't really know where to put it. And we were saying, we don't want to put it in the core because we can't maintain it in the long run, or we can't guarantee it at least. So that's why we created this thing called the Quarkiverse, and the Quarkiverse Hub, I think is the name we ended up with, is an organization that is on GitHub that we maintain, but anyone who is willing to come up and show want to contribute like you did with Google Cloud and Google Functions, they can add an extension, and they follow the same structure, the same kind of build system, so that we can anyone can kind of participate. But it's your repo, it's you who manage it, and that you were one of the first one who got in there. So thanks for being what's called a
guinea pig.
A guinea pig, yeah. And by the way, Loïc, I want to say thank you because you did this Hacktoberfest. You did a video on Quarkus Insights on how to contribute the first time to Quarkus. So that one is in the Quarkus Insights. So and you also wrote a little bit of guide and that kind of thing. So thank you for that.
Thank you. Yes, to complete the GCP support in Quarkus, there is also new guides that show how to deploy Quarkus applications to Cloud Functions, of course, because there is a support for Cloud Functions, but also to App Engines and with Cloud Run. So now we have inside Quarkus a complete support for GCP. And this was the purpose.
Yeah.
When you say GCP, Google Cloud Platform, right?
Yeah, Google Cloud Platform.
Yes. I heard TCP first. I was like, what? I'm confused.
Oh, GCP. Yeah.
Awesome. Anyway, Loïc, let's get going. We want to talk about the stuff. So if you want to share the screen now, or
Yeah. Yes. Okay.
Okay. So, there you go.
So I will introduce the multiple extensions via demo application. So imagine I want to manage bookmarks, okay, because I love to bookmark stuff on the internet, but I don't want really to build a graphical interface. So as I'm more a guy with a shell, I will use Bash to create new bookmarks with the bookmarks managed as JSON. Okay, so I will use the gsutil command to send a JSON file to cloud storage, and this is my graphical interface. Okay, so I will send JSON in Google Cloud Storage. Then I want to handle them, so handle my JSON. For this, I will create a Cloud function that will listen to a Cloud Storage event, and when I receive this event, I will load the file from Cloud Storage and send it to PubSub. I will have a second Cloud function that it will listen for messages from Cloud PubSub, then connect to Cloud Firestore database. Cloud Firestore, it's a NoSQL database from Google. It's a document-oriented database, and then I will store my bookmark in it. And finally, I will build an API, so Cloud Functions and HTTP Cloud Functions to be able to access those bookmarks via HTTP. So this is the application I will build today. This application is what
for people who are not super familiar with the Google universe. So cloud storage is really to store a file, right?
Yes.
Then you can, a function is a piece of code that can react to the fact that something has been stored somewhere and do something.
Yeah.
Well, PubSub is really a messaging system where you say, okay, I'm sending an event, and then anybody can, well, some people can listen to that event and react to it. In this case, you did attach a piece of code called a function. And Firestore, you said is a database. Is there any specific, like specificities to that database?
It's a document-oriented database. It's a bit special. Okay. You create you put JSON document at some path in the database, and you retrieve it from its path. So it's really key JSON document.
Okay, cool.
Yeah, and I will use two kind of Cloud functions. So background event to react to a Cloud Storage event or PubSub event, and an HTTP function. This is a typical kind of Cloud Native application. So it's Cloud Native because it's an application that is built on the capacity that offers public cloud. So here Google Cloud, and it uses a function as a way to deploy the code. And what is interesting with a function is that it scales to 0. You don't have to manage the infrastructure. You just deploy code to your cloud provider, and your cloud provider will just run your code and take the decision to scale when it's needed. So it's very interesting because you have free quotas to run your code inside Cloud Functions. So I will start. So I will start with my first function. So the function that listens to Cloud Storage event and use a background function to load the object from Cloud Storage and send the content of the object to Cloud PubSub. So for this, I'll build a background function. So I really use the background function API from Google Cloud Functions library. So this is a storage function. This is the name of my function. I need to this function needs to be CDI bin because our Quarkus because it's the way our Quarkus can find the function. I will explain a little. I will explain later some stuff about it, how it works internally. But for the moment, you just you just must add a CDI annotation, so your function is a CDI bean. Okay. As I use this other Google Cloud Function API, I need to implement the accept method. This method accepts my events. So this event is just a puzzle that I built from the Google Cloud Storage event description on the Google Cloud Storage API. So my function will receive the storage event. Then I can get the name of the object from the name attribute of the storage event. So what I would want here is to load the file content and send it to PubSub. So I will implement this a little later. For now, I will just try to deploy this function inside Google Cloud.
So maybe I missed it, but which extension did you add to get to this stage?
Excuse me, can you repeat?
Maybe I missed it. Which extensions did you add? I assume you added something.
Yeah. So this extension to be able to deploy Cloud Function as a Quarkus application, it's called the Quarkus Google Cloud Functions. It's part of the Quarkus core extension, and it's allow us to have Google Cloud Functions support inside Quarkus. So as I said, you create a standard Cloud Function, Google Cloud Function. So this is really a function that implements the API from Google Cloud, and then you can deploy a Quarkus application inside a function. So this is here my project. So I will just build the function using Maven as usual. Then I can deploy this function inside Google Cloud using the Gcloud tool. So the Gcloud command line is a bit complex. I will explain it just after. So I use Gcloud beta functions deploy. So this is a command line to deploy a function inside Google Cloud. I name this function Quarkus GCP demo storage. Then I need to configure the entry point. This is very important. The entry point, it's not the function and just what, it's the Quarkus background function. The Quarkus background function will bootstrap Quarkus, then search inside the CDI container an implementation of a background function. This is the function that will start everything. Then I configured the trigger of my function. So I say that it is trigger on Google Cloud Storage object finalize event and on the Quarkus GCP bucket. I use the runtime Java 11. This is the only Java runtime available with Google Cloud Function, and I use a source from the target deployment directory. When I build my application with MVN clean package, it packages my application and as a jar and put it inside the deployment target deployment directory, because Google Cloud Functions must use directory with only one artifact in it. So here the deployment is done.
Wait, that's the limitation of, so that's the Google Cloud tool that expects there to be just one jar inside the...
Yes, there is multiple ways to deploy to Google Cloud. You can have a Maven plugin that builds your function. You can upload all the code and he build it for you. But the easiest way to to control the way the packaging is done and stuff like this is to generate a browser on our side and send it to Google Cloud Function. It's just easier way. This is why we implement this one.
Got it. But we got
Max,
yeah.
Yeah, there was a question from Matthews.
Yeah, that's the one here. Yeah. What is the difference between the Maven groups IO Quarkus and IO Quarkiverse? So I can take that one. So IO Quarkus is the traditional one we have for the core platform. And then when we started doing hey, we want to have other extensions out there, which might be from outside the main team or main stuff. So we decided to introduce this notion of Quarkiverse, which is just another group artifact name where this organization we had that's called Quarkiverse can publish into. So it's just to have a place where external contributions can publish to without us having to share secrets between the two groups, basically. So it's more a practical thing than anything to put on it. Put on it.
Yeah.
Does that make sense?
Just like an even like wider background. Like anybody can write a Quarkus extension. So you can do, you know, I don't know where you come from, Matthews, but let's say you come from France, fr.matthews.my extension that will do something at build time with Quarkus and then, you know, offer something at runtime. You can write that, you can deploy that on Maven, put that on GitHub or somewhere else, and anybody will be able to use it. You just have to add it to the POM of your Quarkus application and you're done with it. So Quarkiverse is just a way to simplify that for people, you know, especially individuals like Loïc that do not want to maintain a website, do not want to maintain a GitHub organization separated, want to like maintain the publication via Sonatype to push it to Maven and whatnot, right? So that's an easier way for contributors to add more extensions to the Quarkus extension universe.
Yep. Cool. So go ahead, Louis.
Yeah. So one thing that you can notice is that I'm using the smallest cloud function available on Google Cloud. My function only used 256 megabytes of memory, and it's more than what's needed for Quarkus application.
Cool. Does Google actually have a free tier, or how much?
Yeah.
Okay, I haven't even tried in a while. So all this runs in your free tier. That's what you're saying.
Yes, everything works runs on my free tier for this demo.
Awesome.
So this is the logs from Google Cloud functions, and you can see that that it started Quarkus in 1.5 seconds, and that the function took 3 seconds to start because the function ran inside a Jetty application server, so the Jetty application server needs to be started also. So I can test my function.
SDK for the SDK is an abstraction, and then they use Jetty in this case as the engine to run.
This is the engine of Google Cloud Functions.
Right.
So as I explained, I will use JSUtil to send a bookmark. So a JSON bookmark. I can show you the JSON I sent. Yes, just missing one dot. So this is the JSON I just sent to the Quarkus GCP bucket. And by uploading the object on the bucket, this triggers the function, and I show the log receive storage event for object bookmark 1.json. Okay, so it's working. Now I will implement my function. So I will load the object from cloud storage and send it to PubSub. For this, I will need a storage object. I can inject it directly inside my function because I have Quarkiverse cloud storage extension inside my POM dependency inside my POM.xml. So this dependency is the Quarkus Google Cloud Storage extension from the Quarkiverse Google Cloud Services extension set. And this allows me to inject a storage object inside my application.
Let's pause here. So David has an interesting question. Is there a process for having these non-official extensions, like the one you just showed, move to the official Quarkus.io? Max, you want to take that one?
Yeah. So the question is yes and no. So I want to say, like, if by Quarkus.io mean like on code Quarkus.io that I can find them in the code starter, that kind of thing, we are working on making that every extension on Quarkiverse would automatically show up there. That will also include other people's extensions. That they will be able there. If you're talking about hey, we want this, let's say the GCP storage to be part of the core Quarkus platform, then that'll be up to the conversation. Like, does that make sense to have that in the core of Quarkus, or would that more be like an extension that lives outside? And I think depending on how old and how new and how many things we have to change, because once you move over, there will be some API changes because of the package names. So until now, we've said we will take that on a case-by-case basis. But the idea is that we want to get to a place where we don't have to have everything inside the official Quarkus core, because then we will just always be kind of overcrowded or not be able to release because we have to update something we can't maintain. But the idea is that anything that comes up in Quarkiverse or outside IO Quarkus, if it makes sense to make part of core Quarkus, we will do that. But if not, then we are trying to make sure every tool, every IDE, anything that we have around notation and stuff will be able to show it in a nice and what's called easy to find fashion.
So let me ask a follow-up question. So the fact that it's io.quarkus means it is in this big monorepo, right? And that's why we don't want to expand it to 1 million dependencies, right? Because it's too long to then build and so on. Would it make sense for a Quarkiverse extension to somehow be part of what is called the platform? So if you go back and show, Loïc, if you show the POM again, like your first extension doesn't have a version in it. The second extension has a version explicitly set here. And the reason is there is a BOM, there is a BOM that you can import that says, if you're within that BOM, like all of your version dependencies will be handled for you by Quarkus. And would it make sense to have the Quarkiverse extension Max somehow be in that BOM so that it's actually as good as a io.quarkus in practice from that point of view?
Yeah, so that all the connections can happen, right? So we could see, let's say the Google Cloud here becomes very high adopted and we think it's good, etc., and it fits in, then we could add it into the platform, and then it's managed as part of the normal Quarkus release.
Yes.
Like we do that today for
the monorepo is part of the Quarkus release that way. And by the way, there are examples. So the people at DataStax that wrote the Cassandra driver. The Cassandra driver, I think, is part of the platform, but it's owned by it's com.datastax.something, right?
Yes.
It's hosted on their Git repo and whatnot. It doesn't matter what your name, your package name is.
Yeah.
If you are concerned that the current Google Cloud Services extension is a one-man project, it's not. There is some people from the official Google Cloud a Java team that helped me building it. So I have direct support with Google Cloud library, Java library team. So it's not a one-man project.
Yeah. Well, the general idea is that you'll start seeing more of these that are not like IO Quarkus, but they are in Quarkiverse or somewhere else. That's the whole idea. We don't want to limit the number of extensions out there to whatever we have time to maintain. And then over time, you'll see stuff.
You mean the initial Quarkus team or something?
Yeah, right. And also Anton says, and you move some existing core extensions to Quarkiverse. That is being discussed. There are some that make sense, but that's also always a choice between what's the impact and that kind of thing.
Yeah, we don't want to break apps just because we want to rename things.
So if we ever do that, there'll be let's call it a slow move of something. But yeah, okay.
Is that a dance move of sort? Like, what's a slow move?
Well, slow move says it'll have to be deprecated and be like, we're not going to touch this for X number of time, and then please go use this instead. And since it's in a different package and group name it, we work as a separate thing. So, yeah.
All right, let's give more time to Loïc because then we're eating on his demo time.
Okay, so I just used the Google Cloud Storage API to retrieve a bucket. So a bucket named Quarkus GCP demo where I upload my object, and they get a blob. A blob is the content of the file that I upload to the bucket. So the name of the blob is the name I receive from the storage event. Then I use this blob to send a message to a PubSub. So I will send a message to PubSub. I have a small sender because it's a little complex to send something to a PubSub, and I will send as the message will be the content of my blob. Here I need the project ID, so I can just inject it inside my application because the project ID is a configuration. It's a mandatory configuration for the Google Cloud Services extension. So I just inject the project ID from my application properties to pass to the PubSub sender. Just to have a quick look how to use the PubSub API. So you create a topic, you create a new publisher, then you create the data to send the message, okay, and then you publish the message, then you wait on the message that the message is sent, and at the end I just shut down the publisher. So it's a native implementation. Is it possible to use a list of storage events? No, I don't think it's supported from Google Cloud Functions. So you really, one function is the result of one event.
Yeah,
it's really the way Cloud Functions works.
Yeah.
It doesn't mean that the client won't batch stuff to send or to receive, but in practice, it's like one event at a time, and functions often are built that way.
Yeah, but you will not have a function started each time. In fact, there is some it starts a function and it sends multiple events to it. So it's the responsibility to the function runtime to decide when to start a new function.
How does that work in is it actually a separate VM or is it the same VM but you just isolate it? Do you know? I haven't looked at Google Cloud.
No, if you use function providers to let the function provider deal with these details for you. So, in fact, I don't care. I just know that when I emit an event, it's received by my function. But when you look at the logs, you can see that sometimes it restarts a function. Okay, so we have an answer from someone from Google. So it's the same container, but okay.
Yeah.
Thanks.
Yeah, so they use Gvisor. So they use a Gvisor isolation, and then they have a VM. And that VM, while it's hot, I guess, can answer, several times the same function.
Awesome.
So I will build again, and I will deploy it.
Guillaume, can you answer whether the same VM is shared across different customers, or if it's one VM per function somehow? Function type, at least.
Doesn't use API engine Flex, I think. No. So this is the first function. I will build the second function. So the second function will listen to a PubSub event. Then it will store in Firestore the document.
Yeah, so Guillaume is telling us it's one VM per function. So you're not sharing the same underwear with some other customer. I guess.
So here I use Firestore, so Google document-oriented database, and I will send the bookmark inside Cloud Firestore. So first, I will deserialize the message received by PubSub. So I will deserialize it inside bookmark portal. Okay. And then I will send it to Firestore. So Firestore, you first get the collection because you put a document in a collection. Then I use this collection to create a new document and then the content of the document with my Postgre. Okay, and I just use get to wait for the future to end. It's because Firestore return API future. I just use get to be sure that the call to Firestore is ended when my function ends. Okay, so this is again a background function. So this is really the same stuff, the same kind of function that's the storage one. So I go a little quicker.
A personal question for you. So you've done the Panache, MongoDB for Panache, with Panache, sorry. I can have my own imposed naming correctly. Are you planning to do a Firestore like with Panache of sort, or it's like a bit much work, and so far you?
Yeah, you know that Panache, it's really a lot of work, and it's I think that Panache is one of the most updated extensions. So there is a lot of new functionalities, a lot of enhancements, also a lot of bug reports in it. So it's really a lot of work to create and maintain a flavor of Panache. Currently, there is 2 flavors, Hibernate and MongoDB.
Yeah.
Maybe someday there will be other one, but it's really a lot of work. So I think for now, this needs to be done on a very used. So if there really need to be a lot of people using this technology and wanted to have simplified API on it.
I'm sure Guillaume, he wants to volunteer before.
Yeah, jump in and do work.
No, but the one of the developer from Google Cloud Java library said that maybe he said that he wanted to work on panache version of. So I just advise him to start with a more easier extension, but maybe someday Guillaume will work with us to provide. Google will work with us to provide panache version of Google database solution.
All right, so let's give it a bit of time.
Yeah. So my second function is deploying. I will show you the third one. I will build a third. Oh, I forget to save it, so I will restart it. So the third function is an HTTP function. So it will react to my endpoint. When I will hit the HTTP endpoint, I want it to send me back the list of bookmarks from Firestore. Again, I will again inject a Firestore inside my function. Oh, sorry. Okay. So, just here, I would just.
Hey, so Ivko is asking an interesting question. Do you think that Google PubSub can be integrated with SmallWire reactive messaging the way that Kafka was integrated? And I think
I will on this one just after.
Ah, okay. All right. Suspense.
Yeah. I really love SmallWire reactive messaging. By the way, I'm a big fan of it. So I will just explain this piece of code, then I will answer this question while my last function is deploying. So this is an HTTP function. It implements HTTP function from Google CloudFunctions API. Again, I need to turn it into a CDI bin. Then I inject Firestore, and then I can just access Firestore, the Firestore collection, and list all documents and map these documents inside bookmark object. And then I use an object mapper, so from Jackson, to generate JSON from my Pojo and write the string representation of my Pojo list inside the writer of the response. Okay, so this is low-level HTTP code.
Yeah. So your first function was using the actual API from Google.
Yes.
This one used an abstraction, but in the end, it's wired to the same engine, or it's doing the same thing. It's just that here, if you really want to, you could move that to another cloud provider. Well, except
no. It's still Google CloudFunctions support. Okay. Yeah, HTTP function. It's HTTP function from Google Cloud. And the previous one was background function. There is two function interface inside Google Cloud Function. One for HTTP, the other one for background function.
Okay.
Then I deploy it. Sorry. Okay, and this time when the Gcloud command line is slightly different, because I just use a trigger HTTP parameter, and the entry point it's the Quarkus HTTP function. So this will bootstrap Quarkus and search the function inside the CDI container. I will just rebuild this one because I'm not sure. Then I'll answer the question. So. There is inside SmallWire reactive messaging PubSub implementation, but this is not actively maintained. I just make some tests a few days ago, and it's very easy to integrate it inside Quarkus. I even have a PR a pull request that do this to the Quarkiverse repository. But the issue is really that this component of small while reactive messaging, it's not actively maintained. So if I create an extension to use it inside Quarkus, this extension will rely on not actively maintained components. So if someone is found to maintain it, this will be very easy to integrate it because it's just merging the PR, the pull request I already have.
Okay. So I guess if you have some free time, there you go. Otherwise, it's always this big balance between what's maintained, and we have enough confidence that it's maintained, not just a one-shot effort, and then it can join the Quarkiverse, for example, as a, let's say, beta level, and then can move up the stack depending on the stability, again, the usefulness and whatnot. So that's how we would gradually, move those to like a super stable level, I guess.
But for PubSub's reactive messaging, it's the issues on the small while side. Okay, so I will just push 3 bookmarks inside my application, and I will just check that they arrive inside the Firestore database, that I can list them inside my HTTP endpoint. So the endpoint is here. You see this on the output of the function. You have the endpoint, and this should work. Yeah, called start. Of course. This will take some time. The first time it's always a little long. Yeah, you see.
Cool.
Okay. Okay. And you see there is the three bookmarks just arrived here. Usually after this, I make I update my extensions to I update my demo to work with Funky and REST-Z. I don't know if you really have time for this. I can just switch my my Git repo and show the code.
Probably do that.
Yeah. Okay.
And also probably tell people whether you have this code available somehow somewhere.
Not yet.
Not yet. Okay. So I guess if you do it, just tell us, and then we'll say it on the Quarkus Insights. Mention it so people can have a follow-up.
So I'll just show you 2 pieces of code. The current issue with what I show you is that you still use the Quarkus, the Google Cloud Functions API. So your application is tied to the cloud provider you use, so Google Cloud. If you want to have a provider agnostic solution for a background function, you can use Funky. So if you want to know more about Funky, you can just go to the Quarkus website. So Funky is the way to have Cloud Functions built as a single method. So this is a method that annotated with func, and you have multiple Funky ports for each for multiple cloud providers. So the same function can be deployed to Google Cloud, to Amazon Web Service, and to Microsoft Azure. And you see a Funky function just take the function event as method parameters. So this is really the same code, but this code is portable across multiple cloud providers. So Funky is really interesting for this.
So just so I get it right. So Funky, the functions. There's too many functions here. The extensions you made integrate with Funky, so Funky supports the Cloud Functions that way, right? Not Cloud Functions.
Yeah. In fact, you just need to switch extensions. So you replace the Quarkus Google Cloud Functions extension that provides basic raw Google Cloud Functions support with the Quarkus Funky Google Cloud Functions that provide support for Google Cloud Functions through the Funky API. So it's just a different API. You will use the Funky API inside of the Google Cloud one.
Got it.
You can also do it for HTTP function, but for HTTP, I really love JAX-RS. So I wanted to use REST-easy, and you can use it. So you just switch the Quarkus Google Cloud Functions extension by Quarkus Google Cloud Functions HTTP, and this will provide a binding of Google Cloud Functions into Quarkus HTTP stack. So you will be able to implement your function as JAX-RS endpoint, as reactive route, servlet, or Spring Web MVC controller. So here I choose to implement my function as a JAX-RS endpoint. And you see a function that is portable across cloud provider. I can even use it on, deploy it on a native application if I want. As a container inside CloudON, if I no longer want to deploy it as a function, because it's just a JAX-RS application, a standard one. And what is...
why does it still say Google Cloud Function -HTTP then, if it's just a normal HTTP code? There is still some binding, right?
Yeah, there is a binding. In fact, when you do this, you can you will still package your application as a function and deploy it inside Google Cloud Function.
Okay. By the way, I didn't realize, but it's pretty awesome because we integrate at the lower level, which means whatever HTTP flavors you favor inside Quarkus, whether it's JAX-RS or Vertex routes or as you said, the Spring Web approach, then it just works. I never realized, but it's kind of cool.
Yeah, and the same exists for AWS and Azure.
Yeah,
Azure, I'm not sure. Azure, the implementation, I'm not sure it covers all the way to deploy your function, but it works for AWS for sure, because this extension, the Cloud Function extension, has been implemented the same way as the AWS one. Cool. So just to finish, some words on Quarkiverse. Yeah. So just a small word on the Quarkiverse Google Cloud Services. So there is currently extension for BigQuery, Bigtable, Firestore, PubSub, Spanner, Storage. Excuse me?
I just said you've been busy.
I have plenty of time during lockdown, so I work. Yeah.
By the way, Spanner, does that mean I can use the Hibernate integration with Spanner as well, or have you played with that?
No, not yet. And everything works in native.
Very nice.
And we work on improving the native support by using the Google Java library native
That's
support.
You have the conversation with the Google engineers to improve their code to make it native friendly.
Yeah, they start working on native support for all Google Cloud Services, and we incorporate them inside the Quarkiverse Google Cloud Services one by one. Cool. So we are a beta tester for native support for cloud services.
Cool. Well, thank you. Look, I think we're running out of time. Do you have so you'll post your example code to somewhere?
Yeah, I need to do it someday. Yeah.
Someday. Well, please do it today. And then if you want to say
Max,
cool,
we lost you.
You lost me? I'm here.
So anyway, I think what Max was about to say, if you do it, please just let us know, and we'll make sure we forward that information to the Quarkus Insight people or to the Quarkus people. Cool. Thank you, everyone, and see you well next week for another episode.
Yes.
And I guess Max just died, so I have no idea how to stop that thing.
I can.